Hello, today I'm going to show you how to print many parts in a loop. So the printer will remove itself the parts, so you don't have to look after it.
Happy, lucky, when I think about the place I used to be in.
First thing you should know is that you cannot use your stock printing surface. This surface, when it's cold, the part stays on it quite hardly, so you cannot remove it easily. So your printer won't be able to do it. So what you need is a printing surface that when it's hot, the part remains stuck on the surface, and when it's cold, the part can be easily removed by your printer. So you can use like this FR4, which is used for PCB electronics, or you can use as well glass, or maybe some PEI sheets, but in my opinion, even when the bed is cold, it's still hard to remove the part on PEI sheet. So I'd say FR4 or glass. Here we are in Cura. You can see that it takes 1 hour 29 minutes. It's quite long. To quick this up, first we can remove the skirt here. Build plate, skirt, node. Secondly, the quality. You can print 0.4 with 0.4 nozzle. It's okay, but you have to increase the line width, like 0.6. So if I slice, 55 minutes. So it's okay to do that, but you also have to increase the temperature. 225, and the initial layer must be 235 for glass on FR4. The build plate 70. What we can do as well is shell put 5 walls, so the part is kind of quick 100% infill. If you put here 0.57, it's even better. So 48 minutes. We can slightly increase the speed, like 60 and 32 here. 41 minutes. Finally, disable print cooling. You will have stronger parts. Now we can add a second model. An hour 24 minutes for that. I would really recommend you to use 1mm nozzle. That makes the print much faster, like 3 times faster. You go to prepare, PLA nozzle size 1mm. So you need to buy one if you don't have it. Just you can change here the quality. Layer 8 of 0.7, initial 0.6, and line width 1mm of course. So you can see that's much quicker. The only thing is that 1mm nozzle makes more raw results, of course. So I slightly modified this model. The hooks have a shape more adapted to 1mm nozzle. You can find the STL file in the link under the video. The part here has just been printed. As you can see, the bed is 30 degrees, which is sufficiently cold. What we are going to do now is manually make the parts fall into the cardboard box. So we go to motion, move axis. So first X by 10 millimeters. Let's say, yeah, 93. Alright. Then move axis, move Z by 1mm. So the part is 5mm. So we can go to 4mm. That's perfect. Alright, and then move axis and Y. And now the head is going to push the parts. Continue. Alright, and then move back. Alright, that's it. You probably have noticed this transparent shit. It's really useful because if you don't have it, the part can get stuck here and create a disaster. So you really need this, really easy to do. You just have to put it there and to align the holes here with the screw underneath, and you put the screws of bed leveling right there, and then it's attached like this. So what we are going to do now is create a G-code file. Here I called it ejectmove.gcom, and we are going to automatically eject the part with some G-codes. So first one is G28, which is simply homing. Second one is G90, which is absolute positioning. And then we can put the print head in the corner. G0 for move, X0, Y234, which is the maximum of my Y-axis, and then the 15. M0 is the G-code to make the printer wait for user to push the button. You will understand why later. Then what we are going to do is make the head move on the X-axis. Then we make the print head move down till Z till 4 millimeters. As I said, the part is 5 millimeters, so 4 millimeters is perfect. Then we push the part using G0, Y0. We make the print head move up by 3 centimeters. And finally, we go back to the corner. I saved this file and let's try to kind of print it. That print nothing, but we will be able to see what the printer does with it and to check if that's fine. Go to print from media and you can see that my file eject move is there. I use it and I say print. So it's not gonna print anything, it's just to test our G-code. So as you can see, it's doing the homing. And then it goes to the corner, as expected. You see now on the screen, click to resume. Before that, I'm placing the parts like if they have just been printed. So it's more or less like this. And I push on the button to resume. Okay, you can see the movement is perfect. So let's use it now. Here is the G-code generated by Cura. We are going to remove a lot of stuff here and add our own stuff to make the automatic eject move. First thing is to remove what we don't need. At the beginning, on the ender 3, there's a line which is generated. So we are going to remove that line and everything over. Bye bye. Okay, we can write beginning of the loop here. With M104 and M190, we can set the hot head temperature and bed temperature. So first layer to 235 degrees and bed 70 degrees for the whole print. Those commands make the printer wait for temperatures to be reached. Once that's done, we can do our own G28. People using BL Touch or bed leveling sensors would probably like to add the bed leveling G29 G-code, but I don't recommend to do that. Instead, I recommend you to, when you turn on the printer, make the bed leveling from the LCD menu and then store the settings and load them with this G-code M420S1. You will restore the mesh leveling that you just did. So instead of doing many times the bed leveling, which is useless, you just do it once manually, and then with this G-code you restore it. People who don't use automatic bed leveling can use this command anyway. It doesn't matter. That's for the beginning. I just checked my layer 1 by looking for layer 1 pattern that my bed is still 70 degrees, and also I add M104 to set the temperature to 225 degrees now. We don't need to keep it 235 degrees. Now I go to the end of the G-code file, and here as well I can remove a lot of stuff. First those comments, and then all of this. Instead of that, what we're going to right here is put the printhead in standby position, set the hot end temperature to 65 degrees, which is our standby temperature. But the most important part is set the bed temperature to 30 degrees. We wait here for the bed to cool down to 30 degrees, because that's the temperature where the part can move easily from the bed. Once 30 degrees are reached, we can add our eject procedure. Move X, move Z down, push part, move Z up, and then go back to standby position. Then you can release the steppers using this G-code. And final G-code M82 for absolute extrusion mode. That's the end of 2 parts print. So I can write here end of loop. That's not really a loop, it's just a session, but if I want to automatically reproduce that, I just select the whole file, like here, beginning here, Ctrl C, Ctrl V, and that's it. I've got it twice. I can make a third session, Ctrl V again, end of loop 3, and you can do that as much as you want for 24 hours, 48 hours as you want. I save it and put it in the machine. You will find in the links below 2 G-codes, one for 1mm nozzle, one for 0.4mm nozzle, both for Ender 3. Hope you enjoy it. Thanks for watching.